Hello dear friends, welcome to the YouTube channel of Chem Lover. Today we will discuss one of the important NAM reaction for CSIR NET exam, and this is also very important for GATE exam aspirants. So the reaction is APPEL reaction. So this is one of the NAM reaction that may be asked in near future. So let us discuss this APPEL reaction. So whenever we have a NAM reaction, we have to know first what is substrate in the reaction, and then what are the reagents in the reaction, and what is the stereochemistry of the product. So today's reaction is APPEL reaction. APPEL reaction. We will discuss APPEL reaction. So in this APPEL reaction, our substrate is alcohol. So in this case, the substrate is alcohol. Alcohol is substrate. This is our substrate. And the reagent for this reaction is, so this is the easiest way to remember NAM reactions. We have to remember substrate first and the reagent. So the reagent for this reaction is, PPH3, that's triphenylphosphine and halogen. Triphenylphosphine and halogen, that is CX4. Where our X is chlorine, bromine or iodine, means we can have CCl4, CBr4 or CI4. These are the reagents. So in this reaction, what happens when this our substrate alcohol reacts with the reagent like PPH3, that's triphenylphosphine, and CX4, the product that is formed, that's haloalkane. The product that's formed over here is haloalkane, and the stereochemistry is with complete inversion. So inverted stereochemistry, inversion takes place in this reaction. This is the crux of the topic, inversion takes place. We will also see what is the driving force of this reaction. So first we will write down the reaction. For example, this is the substrate for me. Over here I have OH group which lies above the plane, means the stereochemistry of this OH group, it is above the plane. And we have two R groups, this is R1 and this is R2. So it reacts with the reagent. The reagent in this case is PPH3, that's triphenylphosphine, and we have a reagent like CCl4. We have a reagent PPH3 and CCl4, carbon tetrachloride. So what happens? Overall the product is replacement of this, substitution of this OH group by Cl group, but the product has inverted stereochemistry. So what will be the stereochemistry of the product? That will be this. This is our R1. This is our R2, and over here we have a chlorine substituted product, that's haloalkane. If I use CBr over here, then we have Br over here, CI4 over here, then we have iodine over here. So over here this lies above the plane, and the chlorine which attacks over here, which gets substituted over here, it attacks below the plane, means complete inversion takes place. This is inverted product. So this is inverted product that is formed in this case. So let us check the mechanism of the reaction. What is the driving force of this reaction? We'll check mechanism. So what is the mechanism of the reaction? Let us check the mechanism of the reaction. In the first step of the reaction, step first, triphenylphosphine, that is PPH3. We know that there is a lone pair of electron on phosphorus. It reacts with carbon tetrachloride. So first these two reagents react together. Now this is our carbon tetrachloride. So what happens when triphenylphosphine reacts with carbon tetrachloride? This lone pair of electron, it attacks this chlorine, and this bond breaks. We get a negative charge over here. Means what is formed over here? We get carbon with negative charge, and over here we have chlorine, chlorine, and chlorine. This is one of the species that's formed. Plus we will get PPH3, and to this PPH3 our chlorine gets attached. This is the side product that is formed. Now in the next step of the reaction, what happens? This negatively charged anion, it attacks alcohol. So I will react in the next step. This negatively charged anion reacts with alcohol. And the next step, what happens? This is my alcohol. This is R1. Let us suppose this is R2. And over here we have a OH group which lies above the plane. This OH group is above the plane. So what happens in the next step? This negative charge attacks this proton, and this bond breaks towards oxygen atom. So we have a negatively charged oxygen over here. So what is formed in the next step? In the next step we get a species like this. R1, R2, and on this oxygen atom we have a negative charge. This is the type of the intermediate that's formed. This is the type of the species that's formed. But this is above the plane. So this thing is above the plane. Now this attacks this type of species which is formed. Since lone pair of electron takes place, therefore we have a positive charge over here. So attack of this triphenyl phosphonium chloride, it takes on this negatively charged oxygen atom. So we have PPH3 and chlorine attached to it and positive charge over here. So what happens over here? This negatively charged species attacks this phosphorus and this chlorine leaves as Cl minus. So in the next step, what we are going to get? So we get this type of species. This is our R1 and this is our R2. Let me write it like this. And over here we have above the plane oxygen. This oxygen attacks triphenyl phosphine, that's PPH3. Over here we have a positive charge. Now what happens? Since the formation of P double bond O, it's a very stable compound. This is the driving force of the reaction. So this bond will break towards this side and we get a positive charge over here. To this positive charge our Cl minus attacks. Now the Cl minus has to attack from the back side because it's an SN2 reaction. So Cl minus attacks from the back side because it's SN2 reaction. That's why inversion takes place. And the what is formed over here? So we get this type of product R1, R2, and we have chlorine below the plane. Now why this chlorine comes below the plane? Because it's SN2 reaction. In SN2 reaction, this side is already blocked. So this is not a very good leaving group. That's why carbocation will not be formed. So Cl minus attacks below the plane and this compound is lost over here. What is lost? PPH3 double bond O. Formation of this P double bond O, it's the driving force of this reaction. So this is the product of the reaction. It's an inverted product. This whole is the flow chart of Apple reaction. This Apple reaction is very important for your competitive exams. Let us take the example of this Apple reaction. Let me take one of the example. So we'll discuss over here. We'll discuss example. I have this type of compound. So how can you know in the examination that this is an Apple reaction? So basically you can recognize the Apple reaction from the substrate and the reagents. That's why remembering of substrate and the reagent, it's very important. So I have this type of compound. Although this looks a very big molecule, but the reaction is very easy. So over here I have OH and over here I have OH above the plane. Over here I have OH above the plane. So I treat this compound with the reagent PPH3 triphenyl phosphine and CCl4. So what happens overall in the reaction? Cl minus attacks this opposite to that of this plane. Means Cl minus attacks from below the plane. So what happens? This OH is lost and Cl comes in this place. So overall substitution takes place. So this is my Me, this is Me. Over here I have O, over here I have O, and I get this type of product. So this is pH, this is pH. Over here we get chlorine, and this is pH, this is pH. Over here we have OH group. If I use excess of this reagent, then this also may get substituted over here. So guys, this was all about Apple reaction. I hope you might have enjoyed this reaction. If you really like this video, please like, share and subscribe. In the near future, I am going to take all the reactions and will discuss all important topics of for CSIR NET exam. Thanks for watching this video.